The hardest part of dynamics isn't the math. It's watching professors remove the fun from perfectly good fun things. Welcome to day 1 of Surviving Dynamics. Today, we're doing a finals week style problem. Here's the setup. We've got a Ferris wheel rotating counterclockwise at 1 radian per second, and it's slowing down with an angular acceleration of negative -0.1 radians per second squared. We want the velocity and acceleration of 3 passengers sitting 90 degrees apart, written in x and y components. First, let's picture the problem. Draw the wheel, put the x and y axes at the center, and place the passengers around the circle. Passenger 1 is at the top, passenger 2 is on the left, and passenger 3 is at the bottom. Now let's figure out the velocity directions. Remember, velocity on a rotating wheel is always tangent to the circle. For velocity, we start with the polar coordinate equation. At first, it looks like there are 2 pieces to worry about, a radial part and a tangential side. But there's good news. The radius of the Ferris wheel isn't changing, so the radial term disappears immediately. That leaves us with only the tangential velocity term. And if you have no clue what these symbols mean, don't let them scare you. E sub r and E sub theta are just unit vectors. One points away from the center and the other follows the direction of motion. Now here's the nice part. All 3 passengers have the same speed. The only thing changing is the direction. Just follow the tangent. Left at the top, up on the side, and right at the bottom. Same speed. Different directions. Now let's do acceleration. This is where dynamics starts feeling a little like dynamics. Acceleration has 2 pieces, a radial component and a tangential component. The radial component points toward the center of the wheel and keeps the passenger moving in a circle. The tangential component follows the motion and comes from the wheel speeding up or slowing down. And since this Ferris wheel is slowing down, the tangential acceleration points opposite the direction of motion. So before touching a calculator, sketch those 2 directions first. Draw the radial arrow along the center. Then draw the tangential arrow along the circle. Once those directions look right, convert them into x and y components. And that's really the whole strategy. Start with radial and tangential components, then translate everything into x and y. And honestly, that's a huge chunk of early dynamics. What's the weirdest thing a professor has turned into an exam question? Drop it in the comments. If you're taking dynamics this semester or taking a final soon, save this video because we're engineering our way through the entire course. And like and follow Luna V Lab for day 2 and more engineering walkthroughs.